Hello, my name is Sydney Ju, and my partners are Natalie Leon and Tiara Smith. Our project is a web interface to identify SEO success factors. This project is meant for small to medium enterprises, also called SMEs. Since SMEs are in competition with each other as well as larger enterprises, it has become a necessity in our modern age to have a large digital presence. An enterprise's digital exposure will most likely come through search engine result pages, also called SERPs. These pages are generated by engines such as Google and Bing. SMEs often do not take advantage of search engine optimizations, also called SEOs, that are necessary to appear at the top of Google SERPs. Our solution to this dilemma is a two-part project that uses Python code on the back end and a web page used to display the results as the front end. Our program will be analyzing keywords in SERPs for similarities between keywords, clustering web pages into groups, and providing feedback for a given SME website. The results and feedback provided will guide the user to boost their SEOs by suggesting keywords and metadata modifications for their site. This program will also provide feedback for a selected cluster group, guiding the user even further by telling them how to get their website into a specific cluster group.
Following our diagram, our program starts with a user-inputted keyword. This keyword is placed into Google Ads. Google Ads is an API that takes a keyword and gives related keywords. In our case, 50 keywords are needed. These 50 keywords are placed into a separate API that give the SERPs for each keyword. The results are stored into a CSV file. This CSV file is needed in order to calculate the similarity between the URLs. This results in a similarity matrix, which is stored into a separate CSV file. This separate CSV file is needed when performing our clustering algorithm. Our clustering algorithm clusters our information into groups depending on the number of groups that the user needs. After finding the results of our clustering algorithm, we sort our user-inputted URL into the group that best fits the user's URL. When finding which group the user best fits, we then generate suggestions in order to improve their successfulness. We recommend certain keywords, or we recommend removing keywords. We also recommend other tools that might help the successfulness of the user's URL. These results are stored into a database, which is then used in order to display the results onto a web page. Our algorithm is a hierarchical clustering algorithm, which calculates the distance between each input element and the following input element. Our algorithm continues until n minus the number of groups which the user desired is reached. Our results are as needed. Our program runs smoothly and does everything that is needed. It provides the suggestions when a URL and a keyword are given.
Our program runs from the command line and updates a web interface that is used to communicate feedback and suggestions to the user. The program is broken up into a series of Python scripts that is run sequentially. We start the program by running our google.py program with a parameter, and this parameter is the keyword or word phrase that will be given to the Google keywords, which will then return the 50 top related keywords or keyword phrases. So the first thing that our program does is navigate to Google Keyword Planner website, and as a security measure, traffic to this website is guarded by a two-factor authentication. So it is going to ask us for a Google security code that is texted to my phone. And the code is 5273. So then after entering the code, the navigation to the keyword planner completes. The web crawler is programmed to find the elements I need to continue to the web page. It will enter the keyword from the command line parameter and click on the button to generate 50 keywords. These 50 words are then stored into a wordlist.txt file that is used for the next part of our program. Alrighty, so once the wordlist.txt file is generated, it is passed off to an API provided by Dr. Lay. That will generate the search engine results page for each of the 50 words. This is compiled into a CSV file called raw data.csv, and it will take a while due to its sheer size. Okay, so after we have our data, the program then starts to calculate and generate a similarity matrix. Using this data, we SERP for each word in our data contains 10 URLs that we will analyze for similarity. The similarity that we're looking for is the similarity between the URLs. For this, we will look at the URL itself and any related metadata, such as the descriptions or keywords. And after the similarities between each URL is calculated, a correlation matrix is generated by using the similarity matrix. And after we have our correlation matrix, the final part of the program begins. The correlation matrix is fed into a clustering algorithm, and the user is asked for how many clusters they would like to be created, which in our case, I would say 5. The desired number of clusters is generated, and the program then asks for the user's business URL, which I have copied and pasted a random URL, I believe. There we go. This URL is then analyzed and placed into the most appropriate cluster group. The user is then asked which cluster group they would like to belong to. Which I would say probably, let's say 2. Lastly, the best and worst words for the descriptions of each URL in each cluster group are discovered and grouped. The best and worst words for the user selected cluster are placed into a whitelist and blacklist respectively, and the results are displayed on our web interface. So I will stop sharing my terminal since it completely ran through the program. So this is our website where all the data of our results are displayed from the program. And then we have our suggestions tab. This is where the suggestions for your business URL are displayed. We give you a list of words that we think will improve your SERP results and some words that you should remove. In our case, the green one is highly recommended, and we should probably include some of these words. And it tells us what words that we should remove or replace in our current description from the business URL that I entered. So our cluster results tab, this is where the results of our clustering algorithm are stored, and here you may view the clustering heat map or download the results. So this link right here is the initial clustering, and this is the one including the user's business URL. This is where the correlation matrix is stored, and it too can be downloaded. And this About Us tab gives us a brief synopsis of our project and contains links to our CS department web pages. And finally, clicking this will take us to Dr. Lay's webpage for our project.